Today's going to be our last lesson involving rational exponents. Already alluded to this with a few of our examples yesterday, that rational exponents are very useful when performing operations between radicals that don't have the same index. Okay, so here notice the directions for these two problems. We're trying to rewrite as a single radical using the smallest root possible. Notice I'm over on the left side, I'm multiplying a cube root by a fourth root. Since they don't have the same index, I can't just multiply my radicands together, right? So it's going to be beneficial to rewrite these both in their rational exponent form. Cube root of 2 to the fourth power, we know that's the same as 2 raised to the 4/3. And then the fourth root of 2 to the fifth would be the same as 2 raised to the 5/4 power, right? Now I can apply a property of exponents, and I can add the 4/3 with the 5/4. That's going to require a common denominator here. Okay, so that common denominator is 12. 4/3 turns into 16/12, and then 5/4 going to turn into 15/12. I'll add these together. That'll give me 31/12. All right, now we saw yesterday in one of our examples, once we got here, the fraction reduced. You definitely would want to check for that. In this particular case, it doesn't. So we're going to rewrite this as the 12th root of 2 to the 31st, okay? And I can definitely do some simplifying here, so don't actually try to raise 2 to the 31st power. I'm going to treat this more like the 2 is a variable right now. And I'm going to break this up so that I get a power on 2 that's divisible by 12. I'll take 2 to the 31st, and let's think of it as 2 to the 24th multiplied by 2 to the 7th. Okay, now if I take the 12th root of 2 to the 4th, wouldn't that just be 2 squared? Right, 24 divided by 12 gives me 2. And then I would have that be multiplied by the 12th root of 2 to the 7th. Okay, and then, of course, I can change the 2 squared to 4. Okay. And we could raise that 2 to the 7th. So that becomes 4 times the 12th root of 128. Okay. All right, second example, notice I've got some variables here. Square root of x cubed divided by the cube root of x to the 4th. Notice, again, the radicals don't have the same index, so it's going to be helpful to go here. X to the 3/2 power divided by x to the 4/3 power. And now, property of exponents in the division case here allows me to subtract the power of the numerator by the power of the denominator. Okay, get yourself a common denominator of 6. And you're going to end up with x raised to the 1/6 power, which is simply just the 6th root of x. Okay. Couple more examples. Notice same directions, rewriting as a single radical with the smallest root possible. Okay, so over on the left here, I have a radical within a radical. So I'm taking the 4th root of the 5th root of a squared. How about I start by making the 5th root of a squared? Isn't that a to the 2/5 power? Okay. And then a to the 2/5 power, if you're taking that if you're finding the fourth root of that, that would be a to the 2/5, then raised to the 1/4 power, right? Now I can multiply my two powers together. It's going to be 2/20, reduce that to 1/10. And now I can make this the 10th root of a. Okay. Next, square root of x cubed divided by x to the 1/3 power. If I were to try to take that denominator and put it in its radical form, I'd have a cube root, which doesn't have the same index as the numerator. So it's actually going to be beneficial to convert the numerator into exponent form. Let's make this x to the 3/2 divided by x to the 1/3. And once we're here, it's pretty similar to a couple examples ago. We're going to subtract the power of the numerator by the power of the, if I have a moment of dyslexia there, it should be 3/2. Subtract that by 1/3. Okay, so get yourself a common denominator. Okay, 9/6 minus 2/6, that's of course 7/6, right? That's going to give me the 6th root of x to the 7th. And then notice you can simplify here a little bit. X to the 7th, let's think of that as x to the 6th times x. 6th root of x to the 6th is, of course, x. And then multiply that by the 6th root of another x. Done. All right. One more practice slide for you to try on your own. Pause the video, work through the problems, and then come back and check your work.